And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of all problems of lead code and geeks for geeks within less than 5 minutes. So without wasting time, let's get started. So today's problem is intersection point in Y-shaped linked lists, which is marked as a medium level problem, and I agree with it. Okay, let's find out what we will be given into this problem and what we have to do. So we have two we will be given two heads, and that will be of two linked lists. Okay, two linked list heads we will be given, and we have to return the value of the intersection point. What does this mean? This means if these two linked lists are combining or joining at any point, I have to return that value. Okay, all right. So basically, and if the linked list do not merge, if they are not merging at any point, I will return -1. So that is it, guys. If we will be given two singly linked lists, and we have to return the point where two linked lists intersect. Okay, all right. I hope the problem statement will be clear. So actually I saw a lot of videos on this problem, but the issue was that many were of 20 minutes, 30 minutes, and I think we engineers are smart. We don't need to spend 30 minutes on these problems. Okay, so I will try to wrap it up quickly by giving some hints and how are we going to approach it. So look, one of the very brute force approaches for look, two linked lists are there, one head, second head. So what I will do is I will be moving one head, like it will be n square time complexity. First of all, I will be moving one head, like I'm currently at this 4 and I'm checking for this. I will iterate over this whole linked list for this 4. I will check if this 4 is equal to any of this. No. Okay, all right. Again move forward. I will again check this node for all the values for all the linked list nodes of the second linked list. Is this equal? No. Okay, I will move on. I will again check this 4. Is this equal to any of this linked list? No. Okay, I will again move forward. Is this equal to any of the linked list? Yes. Okay, so I will simply return 4. That is it, guys. That is it. Okay, so this is one of the approach which we can take, but the time complexity will be big O of n square, because for every node I'm iterating over another linked list. Okay, so if you will see, the size of linked list is 10 raised to the power 5. So it will be something like 10 raised to the power 10, which is not suitable, which will give us time limit exceed. Okay, all right. So, and also another thing is try to solve the problem without using extra space. Okay, all right. So keeping in mind both things, what idea is coming in my mind is, look, if if I'm thinking like I will move one next to this, I will move one next to this. Okay, I will move one next to this, and I will move one next to this. But if I'm following such approach, I will never be able to get the linked list because the lengths are different. Okay, one length is this, one length is this. These two lengths are different. Okay, so if we can, let's say, make sure that two lengths are becoming equal, then we can find the like current. We can simply find. Okay, our I think you guys are getting. So look, here you can see, if there were not this node, if there was not this node, okay, our 6 was, our head 1 was, head 2 was this, head 1 was this. Okay, I will check head 1 is equal to head 2. No. Okay, I will move both next. I will move this and to this. Okay, are they equal? Nodes are equal? No. Okay, I will again move forward. I will check this 8 8. Are they equal? Yes, both nodes are equal, so it means this is our intersection point. I will simply return it. All right, I hope you guys are getting. But the issue is happening is, we the lengths are not equal. So if the lengths are not equal, it's causing the issue. What we can do is, I'm thinking, can we try to equal the linked list, try to equal the length of the linked list. What I will do, I will try to get the, first of all, length of the both linked list. I will try to get the length of both linked list. Okay, this length is 5. Okay, its length is 5. Basically its length is 6. 1 2 3 4 5 6. Okay, 6. So what I will do, if any of the linked list which is larger, I will try to cut it down. I will try to cut this down. I will try to move 5. Okay, now our head 1, head 2 is pointing to this 6. Head 1 is here. Now I think you guys know, just iterate one by one and keep on checking. If its value is equal, return that, and if at last I reach to the null, I will simply return -1. Okay, so that is it, guys. I hope that much will be sufficient to give you an idea and you can think it off. Okay, because programming is all about figuring out. Okay, all right. So in this way also I will do the same thing here. First linked list length is 5, another linked list length is 3. So what I will do, I will try to cut these two. I will first of all cut these two linked list nodes. Our head 1 will be head here starting, head 2 will be here, and again I will run the same loop as I told, and if they are not equal, move next to both. Okay, all right. I hope the problem explanation will be clear. How are we going to approach this will be clear, and now we can write the code of it. But before writing the code, if you want to give mock interviews of DSA as well as front end, so I have attached a form, Google form, where you can fill the form, and I'm going to take the interview of it. Okay, So moving on, and if you love the explanation, please don't forget to subscribe the channel as well. Okay, all right, two things I have said. Moving on to the code part. Look, this I've written this function to get the length of both linked lists, because I have to get the length of linked list. Okay, all right. So let's say int L1 is equal to length, and I will pass head1. Okay. Similarly, I will do something like int L2 is equal to length of head2. Okay. Now look, if L1 is greater, I will push our head1. If L2 is greater, I will push our head2. Okay. So I can simply write while L1 is greater than L2. Okay. What I will do, I will make something like head1 is equal to head1 dot next and L1 minus minus. Okay. I hope this will be clear. Moving on, I will do the same thing with L2. I can also write if statements and all, but I think that is not needed. While L1 is less than L2, okay, I will now move our head2. Head2 is equal to head2 dot next and L2 minus minus. Okay, so when I will come to this 142 line, our length of both linked list will be equal. Okay, all right. After that, what I will do is while head1 not equal to null, okay, and head1 not equal to head2. Okay, all right, means it until I have not reached the last of the linked list and I have not found the intersection point, I will keep on moving. So what I will do, I will simply do head1 is equal to head1 dot next. Okay, and head2 is equal to head2 dot next. Okay, all right, and at last I will check return. I will simply return if our head1 is equal to null. Head1 is equal to null. What does this mean? This means there is no intersection point, and I will simply return -1. Otherwise, I will return head1 dot data. Okay. All right. Let's try to compile this, and I hope it will be getting accepted as well. Meanwhile, if you have loved the code, if you have loved the explanation, please don't forget to subscribe the channel and like the video. Okay. All right. Actually, I'm also solving it for a long time after. Okay. So I hope it is getting accepted. I'm going to see you again tomorrow. Till then, keep on coding. And if you want to give mock interview, please fill that Google form in the comments. And bye, guys. Bye.